In January 2024, a nearly new Boeing 737 MAX 9 climbed out of Portland with 177 people on board. Minutes later, part of the fuselage was gone. Not a window shade, not a loose panel inside the cabin. A door plug, a sealed section of the aircraft body, had blown out in flight, leaving a hole in the side of a modern jetliner, while passengers were still strapped into their seats. And this is where the story becomes uncomfortable, because this was not an old aircraft reaching the end of its life. It was not some experimental design being pushed beyond its limits, and it was not the kind of complex, futuristic failure people expect from modern aviation. The part that failed was basic enough to make the whole thing more disturbing. That is why this incident became bigger than one airplane. It raised a question Boeing could not easily explain away. How does one of the most advanced aircraft manufacturers in the world lose control of something this fundamental? The answer does not begin in the sky. It begins much earlier, inside Boeing's factories, inside its supplier network, and inside a manufacturing system that once made the company almost untouchable. Because Boeing's biggest problem may not be that it forgot how to design airplanes. It may be that the system built to manufacture them no longer works like it used to. For decades, Boeing's advantage was not just engineering brilliance. A lot of companies had talented engineers. Boeing's real advantage was something less visible: control. The company designed aircraft, built major sections internally, managed suppliers closely, and kept engineering teams tightly connected to the factory floor. Designers, mechanics, inspectors, and assembly teams were part of the same system. Problems moved quickly through the chain because the people solving them were often physically close to the people finding them. That mattered because aircraft manufacturing is basically controlled complexity. A modern airliner contains millions of parts, thousands of suppliers, and production tolerances so tight that tiny errors can become major safety problems if the system fails to catch them early. And Boeing became extraordinarily good at catching them. That is part of what made the company so dominant for so long. But here is an important distinction. Boeing's old strength was not simply that it knew how to design airplanes. It was that the company controlled the manufacturing system around those airplanes. And those are not the same thing. A brilliant aircraft design can still fail if production discipline weakens. Documentation matters. Inspection matters. Configuration control matters. Factory experience matters. That last part turns out to be important, because when investigators later examined the Alaska Airlines incident, one of the issues identified was ineffective change management related to workforce experience levels. That sounds technical and bureaucratic on paper. It is not. What it really means is that Boeing's system may not have adapted properly as experienced workers left and newer workers entered the factories. And this is where things get complicated, because Boeing did not suddenly collapse overnight. The company still produced world-class aircraft. Airlines still desperately wanted Boeing jets. Demand remained enormous. But inside the system, something had started shifting, slowly at first, then all at once. And many analysts trace the beginning of that shift back to a merger in 1997 that changed Boeing far more than most passengers ever realized. In 1997, Boeing merged with McDonnell Douglas. At the time, the deal looked logical. Boeing gained defense business, scale, and market strength. Wall Street liked it. Investors liked it. On paper, it looked like Boeing was becoming even more powerful. But over time, a different interpretation started emerging inside the aerospace industry. Many former employees, analysts, and aviation observers came to see the merger as more than a financial turning point. They saw it as a cultural one. The argument is not that McDonnell Douglas destroyed Boeing. That is too simplistic. The more credible concern is that Boeing gradually shifted from an engineering-led company toward a company increasingly driven by financial targets, schedules, shareholder pressure, and production efficiency. At first, that may not sound unreasonable. Large corporations have to manage costs. Aircraft programs are brutally expensive. Delays can destroy billions of dollars. But aircraft manufacturing is unusual. In most industries, efficiency problems hurt profits. In aviation, efficiency pressure can eventually reach the aircraft itself. And this is where Boeing's internal balance may have started changing. For decades, engineers traditionally held enormous influence inside the company. Manufacturing concerns could slow production. Safety concerns could delay decisions. Technical teams often carried more authority than financial managers. Over time, many critics argue that balance shifted. Production speed mattered more. Shareholder performance mattered more. Cost control mattered more. And if that sounds abstract, the effects became visible years later. Because once schedule pressure enters a production system, small compromises become easier to justify. A delayed inspection, a supplier issue pushed down the line, a production target that suddenly matters more than a factory slowdown. Individually, none of those decisions look catastrophic. That is usually how industrial systems drift, not through one giant mistake, through hundreds of smaller decisions that slowly reshape how the system behaves under pressure. And nowhere did that pressure become more visible than Boeing's next major gamble, the 787 Dreamliner. When Boeing launched the 787 Dreamliner program, the aircraft itself looked revolutionary. Lighter composite structures, better fuel efficiency, longer range, lower operating costs. Airlines loved the concept almost immediately. But the biggest change was not the airplane. It was the manufacturing strategy behind it. Boeing decided to dramatically expand outsourcing and distribute huge portions of design and manufacturing responsibility across a global supplier network. On paper, the strategy sounded brilliant. Suppliers would take on more financial risk. Major sections of the aircraft would arrive at Boeing already assembled. Development would move faster. Boeing could focus more on integration and final assembly instead of building every critical section internally. That was the vision, and to be fair, parts of it worked. The 787 eventually became a successful aircraft, but the process of getting there exposed problems that now look far more important in hindsight. Because once Boeing spread responsibility across dozens of major suppliers around the world, something else became fragmented too: visibility. Reuters later described Boeing insiders blaming repeated Dreamliner delays on a splintered engineering strategy tied to an extremely complex supplier system. And this is where the story starts feeling less like a series of isolated problems and more like a pattern. The more production became distributed, the harder it became to maintain tight engineering feedback loops. A problem discovered in one part of the chain could take longer to travel back through the system. Supplier quality issues became harder to monitor directly. Documentation became more complicated. Oversight became more layered. And under production pressure, layered systems create blind spots. That does not mean outsourcing automatically fails. Airbus uses enormous supplier networks too. Modern aviation could not function without global manufacturing. But there is a major difference between using suppliers and losing control of the system connecting those suppliers. And some former Boeing employees later argued the company increasingly moved toward the second category, because Boeing was no longer just building airplanes. It was managing a giant industrial network designed to build them. That sounds similar. It is not. Managing a system is different from physically controlling it, especially when schedules tighten, especially when factories are under pressure, especially when airlines are waiting for deliveries and billions of dollars are tied to production targets. And this is where another decision becomes important. In 2005, Boeing sold its Wichita operations, creating Spirit AeroSystems, a supplier that would later become central to 737 fuselage manufacturing. At the time, this looked like another efficient business move. Years later, it would look very different. For most people, Boeing's crisis begins with the 737 MAX crashes. Lion Air Flight 610 in 2018. Ethiopian Airlines Flight 302 in 2019. 346 people lost their lives. Those crashes became one of the biggest corporate and aviation scandals in modern history. Investigations uncovered problems tied to MCOS, certification, internal communication, and management failures. And for a while, it seemed like the public had found the explanation. Boeing rushed a flawed aircraft. End of story. But the deeper investigators looked, the harder it became to isolate the problem to one system or one aircraft. Because underneath the technical failures, another pattern kept appearing. Pressure. Pressure to compete with Airbus. Pressure to avoid delays. Pressure to keep production moving. Pressure inside a manufacturing system that had already become far more fragmented than it used to be. And this is important. The MAX crashes damaged Boeing's reputation, but they did not fully destroy confidence in Boeing's ability to manufacture aircraft. Many people still saw the problem as specific to MCOS and certification. Then Alaska Airlines Flight 1282 happened, and suddenly the fear changed. Because this time, investigators were not looking at a complicated flight control system. They were looking at missing bolts. That distinction matters. A software failure can feel isolated. A production control failure inside a mature aircraft line feels systemic. And once investigators started examining the factory process around the door plug, the story became much harder for Boeing to contain. The NTSB later identified missing removal records, inadequate training, ineffective change management, and failures in guidance and oversight. That is an extraordinary sentence when you think about what modern aircraft manufacturing is supposed to prevent. This was not some futuristic engineering mystery. It was a breakdown in basic manufacturing discipline. And if that is true, then the real problem is no longer one aircraft. The real problem is whether Boeing's production system still catches mistakes before they reach the sky. After the Alaska Airlines incident, the FAA did something unusual. It stopped treating Boeing's problems like isolated technical events. The agency increased direct scrutiny of Boeing's factories, demanded a 90-day corrective action plan, and launched deeper reviews into the company's safety culture and production systems. That shift matters, because for years, modern aircraft manufacturing depended heavily on delegation. Regulators relied on companies like Boeing to manage enormous parts of their own compliance and quality systems internally. Now, regulators themselves appeared less confident in Boeing's ability to monitor those systems without intervention. And Boeing suddenly found itself trapped between two realities. The company needed to increase production. Airlines desperately needed aircraft deliveries. Boeing needed cash flow. The backlog remained massive. But at the exact same time, regulators were demanding slower, more controlled manufacturing processes. That tension is still unresolved, because rebuilding trust in an industrial system is much harder than fixing a single technical defect. You can replace software. You can redesign hardware. But rebuilding manufacturing discipline across thousands of workers, suppliers, inspections, and production decisions takes years. And Boeing's response revealed something important. In 2024, Boeing announced plans to buy Spirit AeroSystems back. That move was not just financial, it was strategic. The company explicitly said the deal was meant to improve safety, engineering integration, quality control, and supply chain stability. If you step back, the implication is remarkable. For decades, Boeing had gradually pushed major portions of manufacturing outward. Now it was trying to pull critical control back inside the company. That is not a small adjustment. That is Boeing effectively admitting that too much distance had developed between design, manufacturing, suppliers, and final assembly. And this is why the story matters far beyond one company. Because Boeing is not just another manufacturer. It is one of the most important industrial companies in the United States. Its aircraft support airlines, exports, defense programs, jobs, and American aerospace influence globally, which means the question facing Boeing now is much bigger than whether one aircraft line can be repaired. The real question is whether one of the world's most important manufacturing systems can rebuild the tight engineering control that once made it trusted in the first place. And right now, nobody fully knows the answer. What makes Boeing's situation so unusual is that demand is not the main problem. The company still has enormous influence. Airlines still need airplanes. Boeing's backlog remains massive. In fact, that may be part of what makes the pressure so dangerous. Because Boeing is trying to recover while operating under intense delivery expectations, regulatory scrutiny, supplier strain, and financial pressure at the same time. That combination is difficult for any industrial system, especially one that already appears to be rebuilding parts of itself while still in motion. And this is where the Boeing story becomes bigger than Boeing. For decades, the company represented something larger about American manufacturing. Not just scale, precision, coordination, the ability to build extremely complex systems safely and repeatedly over long periods of time. That reputation was not created by one aircraft. It was created by a manufacturing culture where engineering authority, production discipline, inspection systems, and factory experience were tightly connected. The concern now is not that Boeing suddenly lost all of that knowledge. The concern is that parts of the system became too fragmented, too pressured, and too disconnected to consistently protect themselves from smaller failures before those failures reach the aircraft. And industrial systems rarely announce when they are drifting. Usually the warning signs look isolated at first. A delay becomes easier to dismiss. A supplier issue gets pushed further down the line. A quality escape looks isolated. A production slowdown feels temporary. Then eventually the pattern becomes impossible to ignore. That is why the Alaska Airlines incident mattered so much. Not because the failure itself was technologically advanced, but because it exposed the possibility that Boeing's deeper vulnerability was organizational. And organizational problems are harder to fix than engineering problems. You can redesign components relatively quickly. Rebuilding manufacturing culture is slower. Rebuilding trust is slower. Rebuilding tight coordination between suppliers, factories, engineers, inspectors, and management may take even longer, which leaves Boeing facing a question that still has not been fully answered. Not whether the company can design world-class aircraft. It clearly still can. The real question is whether Boeing can rebuild the manufacturing system that once made people trust those aircraft without hesitation. Because in aviation, confidence is not built by presentations or public statements. It is built one correctly assembled aircraft at a time.